Hello friends, last time we had seen certain basic concepts pertaining to lines in which we saw slope of the line. There were two formulas through which we need to find the slope of the line, and then we had derived the angle between the line in terms of its slopes. And then we saw two conditions. One condition was that of the two lines to be parallel, and the second one was that of to be perpendicular. So these were the three or four concepts which we saw last time. Based upon that, today we'll see the examples which would be based on these four concepts. So moving on to the first example, let point A with coordinates 6 and 4 and point B with coordinates as 2 and 12 be any points. Then we need to find the slope of the line joining point A and B, that is AB. This is the line. AB is the line wherein we need to calculate its slope. Now we already saw that the formula to find out the slope of the line, let's say m is the slope of the line, then the formula to find out is y2 minus y1 upon x2 minus x1. This is the formula which we saw last time. So we will make the use of this formula since we have two coordinates over here, point A with coordinates as 6 and 4 and point B with coordinates 2 and 12. We'll make use of the values of these coordinates and we'll substitute in our formula both x1 y1 and x2 y2. So let's say I'll keep A coordinates as x1 y1 and B coordinates as x2 y2. So my y2 is 12 since I have took B as my x2 y2 coordinates. So y2 becomes 12 minus y1 is the y coordinates of point A. So 12 minus 4 upon x2. x2 pertains or signifies to the x coordinate of point B, which over here is point 2. I'll write 2 minus x1. x1 which represents the x coordinate of point A, which over here is 6. So 2 minus 6. 12 minus 4 we have it as 8 and 2 minus 6 we have it as minus 4. So when I simplify this form, 8 upon minus 4, I'll get the answer as, we had calculated the slope of the line which is joined by these 2 points A and B, and its value is minus 2. So moving on to our next question, we shall see the next pattern of question which is asked is, what is the value of y? We need to find the value of y so that the line through points A with x coordinate 3 and y coordinate as y and point B with x coordinate as point 2 and 7 is parallel to line through points C with coordinates minus 1 and 4 and B with coordinates 0 and 6. So we need to find the value of y wherein the line through point A and B is parallel to line through point C and D. Now, first of all, in this type of question, we will calculate the slope of both of these lines and then we will equate them with each other since the lines drawn are parallel lines. So we know that the slope of the lines which are parallel are equal. So first of all, we will calculate the slope of line joining A and B. Let's say M1 is the slope of the line which passes through point A and B. Then M1 is equal to, again we will make use of the formula M equal to y2 minus y1 upon x2 minus x1. The same formula would be applied over here. So M1 is equal to 7 minus y upon 2 minus 3. So 2 minus 3 will give me minus 1 in the denominator, and the numerator I'll have 7 minus y. Now in this case I had taken y2 as my 7 and x2 as my 2 and y as my y1 and 3 as my x1. So 7 minus y upon minus 1. So multiplying and divide by minus 1 in both numerator and denominator will give me y minus 7 upon 1, or that is equal to y minus 7. So the value of m1 I have is m1 equal to y minus. I'll name this equation as equation number 1. We shall calculate the slope of the line joined by these 2 points C and D. Let's say the slope pertaining to the line joined by C and D is m2. Then m2 is equal to 6 minus 4 upon 0 minus minus of 1. Over here 6 represents the y coordinate of D and 4 represents the y coordinate of C, and 0 represents the x coordinate of D and minus 1 represents the x coordinate of C. So y2 minus y1 upon x2 minus x1. This is equal to 6 minus 4 equal to 2 upon 0 minus and minus will become plus. So 2 upon 0 plus 1, that is equal to 2 by 1, and that is equal to 2. So we have m2 is equal to 2. I name this equation as equation number 2. Now from equation number 1 and equation number 2 we have the slope, the values of the slope of these two lines. Now it is provided that both these lines are parallel lines. The line joining points A and B and the line joining C and D are parallel lines. Since these two are parallel lines, I can say that value of m1, that is slope of line m1, is equal to the slope of line m2. So what I will do, I can equate the slope of these two lines with each other. Since we have the condition of two lines to be parallel as m1 is equal to m2, where m1 represents the slope of line 1 and m2 represents the slope of line 2. And since both the lines are parallel, I can say that m1 is equal to m2. Now the value of m1 from our equation number 1 is y minus 7, and that is equal to m2. And from equation number 2 we have m2's value as 2. So y minus 7 equal to 2. This implies that y is equal to 7 plus 2, and that is equal to 9. So y equal to 9. So finally we had arrived the value of y, which we were asked in the question that we need to find the value of y when a line passing through point A and B is parallel to a line passing through point C and D. So by this calculation, by equating the slope of both the lines, we had arrived at the value of y. Moving on to the next question, the next pattern of questions, wherein the question says that a quadrilateral has vertices at points. Let me write it. A quadrilateral has vertices at points. First point is minus 4, comma 2. Second point is 2, comma 6. Third point is 8, comma 5, and fourth one is 9, comma minus 7. A quadrilateral has vertices at these 4 points. Then we need to show, or we need to find the nature of the quadrilateral formed by the midpoints of these vertices. Show of quadrilateral formed by midpoints of the lines in these vertices is a parallelogram. Now, we are provided with these four vertices of the quadrilateral. Now, we had already seen section formula in our coordinate geometry, wherein if 2 points are given, let's say these are the 2 points, and the third point divides these points, the third point which is a midpoint, and hence it divides the line segment joining these points. Let me name it as A and B, and the third point as P. Then P divides A and B in the ratio 1:1. So if the coordinates of x1 A is x1 and y1, and coordinates of B is x2, y2, then coordinates of P becomes x1 plus x2 upon 2 and y1 plus y2 upon 2. We had already seen this in the section formula, application of section formula in the coordinate geometry in our earlier standards. The same thing we are going to apply over here. Now, let me first make a quadrilateral pertaining to these points. I'll name these vertices of this quadrilateral as A, B, C and D. Now as per our data, let me put my vertex A with coordinates as -4 and 2, my vertex B with coordinates as 2 and 6, vertex C with coordinates as 8 and 5, and vertex D with coordinates as 9 and -7. So now we need to show that the midpoints or the line joining the midpoints, let me put the midpoints, these are the midpoints of AB, BC, CD and DA respectively. So if I join the midpoints, then the figure or the quadrilateral which I'll get is a parallelogram. I'll name the vertices as P, P, Q, R and S. Now since P is the midpoint of A and B, as per our section formula, the coordinates of P becomes -4 plus 2 upon 2 and 2 plus 6 upon 2. That is, the coordinates of P are -2/2 upon 8/2. So the coordinates becomes -1, 4. Similarly, we will have Q's coordinate, point Q is the midpoint between B and C. So coordinates of Q as per our section formula becomes 2 plus 8 upon 2, 6 plus 5 upon 2, which implies the coordinates of Q to be 5, 11/2. On similar basis, we will calculate the coordinates of R and S respectively. Since R is the midpoint of C and D, we will apply a section formula to calculate the coordinates of R with C and D. And similarly, we will apply section formula for this line segment D and A with coordinates D and coordinates A as the endpoints and S as the midpoint. So as we had calculated the coordinates for P and Q, we shall calculate the coordinates for R, which is equal to 8 plus 9/2 and 5 minus 7/2, which implies coordinates of R is 17/2, -1, and coordinates of point S is equal to 9 minus 4/2 and -7 plus 2/2, which implies coordinates of point SD 5/2 and -5/2. These are the two coordinates. Now, in order to prove that PQRS, that is PQRS is a parallelogram, we shall prove that PQ is parallel to RS and PQ is equal to RS, or else we can prove that PQ is parallel to RS and RQ is parallel to SP. Since it is a parallelogram, so opposite sides are parallel. If opposite sides are parallel, then the slope of this line is equal to slope of this line, and slope of this line is equal to slope of this line. That means slope of PQ is equal to slope of SR, and slope of RQ is equal to slope of SP. So we shall calculate the slope of first PQ. Let M1 be associated with M1 be slope of PQ. Then it implies that M1 is equal to 11 by 2 minus 4 upon 5 minus of minus 1, that is equal to 3 by 2 upon 6, or else it is equal to 3 by 6 into 2. 3 1s are 3 and 3 2s are 6. So we shall get M1 as 1 by 4. Similarly, we shall calculate the slope of line joined by Q and R. Slope of QR, which implies M2 is equal to Y2. Over here I'll take 11 by 2 minus Y1 whole upon X2 minus X1. So this is equal to 11 by 2 plus 1 upon 10 minus 17 upon 2. So this is equal to 13 upon minus 7, which is minus 13 by 17. Similarly, I'll have the slope M3 associated with line joining RS. So M3 equal to slope of RS or SR. So M3 is equal to minus 5 by 2, that is Y2 minus of Y1 whole upon 5 by 2 minus of 17 by 2. This is equal to minus 5 by 2 plus 1 upon minus 12 by 2, that is equal to minus 5 plus 2 whole upon minus 12, which is equal to minus 3 by minus 12 and is equal to 1 by 4. Now let us take the slope associated with line 4, the line that is slope of SP. I'll move forward, slope of this line SP. Now we have the coordinates of P as minus 1 4 and S as 5 by 2 and minus 5 by 2. So we'll make use of that. We'll have M4 is equal to coordinates of y coordinate of S, that is minus 5 by 2, minus of minus 1, that is coordinate of point P. Coordinate of point P is, y coordinate of point P is 4. So I need to take over here as 4. So this value is equal to 4 upon x coordinate of point S, which is 5 by 2, minus x coordinate of point P, that is minus 1. So over here I'll have x coordinate of point S, that is 5 by 2, minus x coordinate of point P, that is minus 1. So this is equal to minus of 5 minus 8 whole upon 5 by 2 plus 1, that is equal to, so we shall have, I need to divide over here by 2 as well. So minus 13 by 2 upon 7 by 2, that is equal to minus 13 by 7. So I can see that the value of M1 is 1 by 4 and value of M3 is 1 by 4. Now since this value of these two slopes are 1 by 4, I can say that PQ is parallel to SR. I can say that PQ is parallel to SR since this value of the slope are equal. Similarly, I see that M2 and M4 have the same value, minus 13 by 7 and minus 13 by 7. So the slope of line passing through Q and R is equal to the slope of line passing through S and P. That means line which passes through QR is parallel to line passes through SP. So line passing through QR is parallel to line passing through S and P. Hence, I can say that the quadrilateral formed by joining the midpoints of the given quadrilateral is a parallelogram, since I have two opposite sides parallel to each other. Hence, this PQRS is a parallelogram. Similarly, last question today, we shall see that if the angle between, if the angle between two lines is pi by 4 and slope of one of the line and slope of one of the line is 1 by 2, then find the slope of the other line. So we had already seen a formula pertaining to the angle between two lines. Let's say theta is the angle between the two lines, then tan theta is equal to mod of m2 minus m1 upon 1 plus m1 into m2, where m2 and m1 are the slope of the two lines respectively. So we are already provided here that the angle between two lines is pi by 4 and the slope of one of the line is 1 by 2. So we shall substitute the value of theta and one of the slope, that is m1, as 1 by 2. So we will get, by substituting theta as pi by 4, we shall get 10 pi by 4 equal to mod of m2 minus m1's value is half plus m2 into 1 by half. Mod complete. Now we already know that 10 pi by 4's value is 1. So we shall have twice of m2 minus 1 upon 2 plus m2 will fetch me value as 1. So since it is a mod, we can say that 2m minus 2m2 minus 1 upon 2 plus m2 is equal to plus or minus 1, since it is a mod. So when we remove the mod, the other side becomes plus or minus 1. So now equating this, we will get two cases. First case is 2m2 minus 1 upon 2 plus m2 equal to 1, and the other case is 2m2 minus 1 upon 2 plus m2 is equal to minus 1. So this equation will fetch me 2m2 minus 1 equal to 2 plus m2. That is equal to 2m2 minus m2. I'll take this m2 on the other side. So it will become minus m2 is equal to 2 plus 1. I'll take this minus 1 on the other side. So it will become plus 1, which implies 2m2 minus m2 is equal to m2 upon is equal to 2 plus 1, that is equal to 3. Now similarly we solve this equation, which says that 2m2 minus 1 equal to minus of 2 plus m2, which implies that 2m2 minus 1 is equal to minus of 2 minus of 2m2. I will bring this minus m2 on the other side, which will give me 2m2 plus m2 is equal to, I will take minus 1 on the other side. So the right hand side becomes minus 2 plus 1. Now 2m2 plus m2 will give me 3m2 is equal to minus 1 by evaluating this. So m2 is equal to minus 1 by 3. So we'll have two values of m2. One is m2 equal to 3 and the other one is m2 equal to 1 by 3. Thanks a lot.